Every Monday morning, something remarkable happens on your phone. Spotify hands you a playlist of 30 songs. You do not ask for this. No human particularly curates this playlist for you. And yet, many of these songs feel like they were chosen by someone who knows you deeply. Songs you have never heard before, from artists you've never discovered, that somehow land exactly right. That playlist is called Discover Weekly. And in this podcast and video, we're going to take it completely apart. We're going to explain every layer of the technology that builds it, and we're going to go from the simplest possible explanation all the way to the actual logic behind it. And we're going to understand why this single feature, a playlist generated automatically overnight for over 40 million people every single Monday, changed how music discovery works. Before we begin, let us establish something important. We try to get as much facts for the opinions that we share. And if you would like to read further, feel free to check the description of this podcast or video below. Spotify today has over 700 million monthly active users. Its music library contains over 100 million songs. According to Spotify's own engineering publications, Discover Weekly generates over 40 million unique personalized playlists every single Monday morning. Each one is different. Each one is built for one specific person based on that person's specific listening behavior. Think about the scale of that for a moment. 40 million unique playlists built overnight every single week without a single human music curator deciding what goes in any of them. When Discover Weekly launched in July 2015, Spotify had approximately 75 million users at the time. The response was immediate and it was overwhelming. According to a December 2015 report from Time magazine, songs in Discover Weekly playlists had been streamed 1.7 billion times since the July launch, in under 6 months. A separately sourced figure indicates the figures reached 1 billion track streams within its first 10 weeks. Think about the stretch of that for a moment. Spotify's 5-year anniversary report published by Spotify in July 2020 confirmed that between July 2015 and June 2020, users had streamed Discover Weekly for over 2.3 billion hours combined. And the impact was just not on the listeners, right? It changed what it meant to be a new artist. Before Discover Weekly, getting discovered on Spotify was largely about being featured in human curated editorial playlists, getting radio plays, or essentially having a marketing budget. After Discover Weekly, a completely unknown artist with no label, no publicity, and no following could release a track and find it in millions of listeners' Monday playlists within days, because the algorithm identified the music part that fit a pattern or test of the millions of people that it shared it with. According to Spotify's own current data, more than 56 million new artists discoveries happen every single week through Discover Weekly, right? Almost 60 million. More than 556 million tracks are saved from Discover Weekly playlists to personal libraries every single year. And 2 million times per week, a listener hears a new artist on Discover Weekly and streams that same artist again within the same session. Since it launched in 2015, Discover Weekly has accumulated more than 100 billion total track streams, according to figures cited in the July 2025 anniversary coverage. That is not a small feature. This is by far one of the most consequential recommendation systems ever built, and it works in a way that is genuinely fascinating once you understand it. We're going to go through a couple of layers to understand how this works. But before we dive into that, let's just imagine for a moment that you have a huge pile of music, right? About 100 million songs to be precise, and a very smart system that has been watching what you and everyone does with these songs, right? You play a song all the way through, the system notices. You skip a song after 10 seconds, the system still notices that. You replay something 3 times in a row, the system definitely notices. You add a track to a playlist you made yourself, it still notices that. You search for an artist right after hearing one of their songs, it still keeps track of that. Now, the system does something clever. It looks for other people who have made the same kinds of choices you have. Not people who say they like the same things, people who actually listen to the same way that you do, right? As revealed by their behavior. It finds those people and then asks, what are those people listening to that you have not yet had? And the answer to that question is essentially the starting point for your Discover Weekly. That is the core idea. Simple. But in practice, Spotify does not run just one version of this. It runs 3 separate versions by complementary systems at the same time, combines what they each find, and uses that combined output to build your playlist. Let us look at all these systems one at a time. The first and most foundational engine is called collaborative filtering. The name sounds technical, but the idea is ancient. It is essentially the same thing that happens when a friend says, you love the album, have you had this one yet? Their recommendation works because they know your taste from observing your behavior over time, and they have broader exposure to music than you do at that particular moment. Collaborative filtering is that process, scaled to hundreds of millions of people simultaneously. Here's how Spotify implements it. Every user who has ever played a song on Spotify creates a data point, not just a record that they played it, but a rich behavioral record. Did they play it once and never return? Did they add it to a playlist? Did they play it again immediately? Did they search for the artist afterwards? Did they skip it within the first 30 seconds? Spotify uses these behavioral signals as the raw material for collaborative filtering. Importantly, Spotify relies primarily on what researchers call implicit feedback, meaning the system reads your actual behavior, not ratings you give explicitly. And you do not have to press a thumbs up, right? Just like you do on social media. The system infers your preference from what you actually do. Now, the mathematical challenge. Spotify has over 700 million users and over 100 million songs. The theoretical table connecting every user to every song would be enormous and almost entirely empty, since any individual person has had only a tiny fraction of all the music that exists. This is called a sparse matrix problem, and it is one of the central challenges in recommendation systems. You'll soon start facing this when you start building yours out. Spotify's solution to this problem is a technique called matrix factorization. Specifically, the system decomposes the large user song matrix into smaller, more manageable components: a user matrix and a song matrix, in which each user and each song is represented by a vector, a list of numbers that captures that entity's position in a multi-dimensional mathematical space. To make this concrete, once matrix factorization runs, every user has a vector that represents their test, and every song has a vector that represents its characteristics as revealed by how people listen to it. To find songs that match your test, the system looks for songs whose vectors are closer to your test vector. And to find people who listen similarly to you, the system finds users whose test vectors are closest to yours, right? So you essentially have brackets in a way. Those clusters of similar tests, those brackets of users with similar tests are sometimes called test clusters or musical neighborhoods. You sit in one of these clusters with many other people who, without necessarily knowing each other or even knowing they share similar tests, make similar listening choices. The system identifies the songs that the people in your neighborhood love that you have not yet heard. And those are the strong candidates for your Discover Weekly in a way, right? Because they like something and you both share similar likes and tests, therefore most likely you're going to like the music. According to analysis of Spotify's engineering approach, Spotify trained its collaborative filtering models using a dataset of approximately 700 million user created playlists, right? So this is essentially every time you go to your account, create your own playlist. That's again another example of your tests. The insight driving this is powerful. A playlist a user creates is a direct expression of their test. And when thousands of people put the same two songs on their playlists, that is a strong signal. Those songs belong in the same musical neighborhood. One important technical note about how Spotify handles the behavioral data: rather than treating a full listen and a partial listen as equivalent, Spotify uses what researchers call weighted matrix factorization. This means that the system weights the system weights different behavior signals differently. A song you have listened to 20 times carries more weight than a song you played once, right? Because you liked it so much, you had to play it over and over on repeat. A song you added to your personal playlist carries more weight than a song that just happened to be playing in the background. The system tries to reflect the strength of your actual engagement, not just its occurrence. The practical result of collaborative filtering is that Spotify builds what is often referred to as a test profile for each user. And this is a mathematical representation of your musical preferences existing in a high dimensional space where similar testing users cluster together naturally without any human ever defining what the clusters should be. All right, that was the first part. Let's move on to the next one, which is natural language processing. The second engine is one that may surprise many people when they first learn about it, right? Spotify does not just study your behavior, it reads the internet. This technique is called natural language processing, or as many often like to call it, NLP, and it addresses a real limitation of collaborative filtering. Collaborative filtering works well for music that many people have already heard. But what about a brand new artist who released their first song last week? There's almost no listening behavior data yet. Collaborative filtering has very little to work with. NLP, in a way, solves part of this problem by giving the algorithm another source of information, language. And here's how it works: Spotify crawls the web continuously. It reads music blogs, reviews, articles, forum discussions, social media posts, interviews, playlist descriptions, any text that essentially talks about the music. Using natural language processing techniques, the system analyzes this text to understand how people describe specific artists and songs. When many different sources use similar language to describe a particular artist, words like dreamy or introspective or sun drenched or pop or shoegaze influenced, the system builds what Spotify's engineering team has called the cultural vectors for that artist. These vectors capture the way people talk about music, which acts as a proxy for the emotional and stylistic qualities of the music itself. The key insight is that two artists can be musically similar without a single listener ever playing both of them back to back. If critics and fans describe them using the same vocabulary, the NLP system will recognize them as neighbors in musical space, even if the collaborative filtering data does not yet show that connection. So, in a way, for a new artist, the NLP engine can place them in the recommendation system much faster than collaborative filtering alone could. If a new artist has been described in the same language that established artists you love were described in, the system can connect them to you quickly. This is one of the core mechanisms by which Discover Weekly helps new artists get discovered. The NLP engine can bridge the gap between a brand new release and an established audience faster than purely behavior systems can. All right, let's move on to engine number 3. And this is audio analysis. So this part is perhaps the most intuitive. Spotify actually listens to the music. right? Using audio analysis techniques, Spotify processes every track in its catalog to extract a set of measurable acoustic properties. These properties are well documented through Spotify's developer API and include the following: the tempo, which is essentially the speed of the track measured in beats per minute, the energy, a measure of intensity and activity, right? A fast, loud, noisy track scores higher on energy, whereas if it's quiet, slow, and acoustic, um, it scores low. Um, and then you have the key, which is essentially the musical key in which the track was written. You have the mod, so whether the track is a major key, which tends to sound brighter, or a minor key, which tends to sound a little bit darker. Um, and then there is loudness, right, which would be the overall volume of the track in decibels. And then you have acousticness, right, a confidence measure of whether the track is acoustic, meaning it's performed primarily with acoustic instruments rather than electronic production. And then you have the groove or danceability, a measure of how suitability, or I mean, a measure of how suitable the track is for dancing, based on the tempo, rhythm, and the beat strength. And you have many others like this. You have valence, a measure of musical positiveness. You have speechness, a measure of the presence of spoken words. You have instrumentals. You have liveliness, right? So together, the measurements create what you can think of as an acoustic fingerprint for every song in Spotify's library. Every song sits in a multi-dimensional acoustic space, right? That's been defined by all these measurements simultaneously, right? So think of all of them together being tracked, and Spotify being able to then decide where, or the system being able to decide where each one of them fits within those dimensions. So the power of audio analysis is that it works regardless of how popular a song is. A track released yesterday by an unknown artist can be fully mapped in acoustic space and compared to every other track in the library. This means Spotify can identify that a new unheard song sounds very similar to tracks you already love, based purely on its acoustic properties without needing any listening behavior data at all. This is the primary mechanism Spotify uses to address what engineers call the cold start problem. Um, and we had already looked at this in the when we were analyzing the Netflix algorithm as well. When a new song exists with no listening history and minimal language coverage online, audio analysis in the engine um, can still surface it to potentially interested users, right? So this also helps in a way for artists to feel like they are being seen and for their music to actually be listened to um, by by the audience, or whether you're running podcasts. All right. Now that we can understand the full picture of how Discover Weekly is built, let's just kind of go through it again, right? So Spotify takes your recent listening history, right? Weighs it together, right? To what you've been playing in the last 30 days, with more recent listenings, of course, carrying more weight, because if you've listened to something recently, it means that is what you're more into currently. And because your test right now matters more than the one before, you're going to be recommended to music more similar to that carrying forward. The collaborative filtering engine identifies the users in your musical neighborhood, people whose listening behavior most closely matches yours, and finds the songs that those neighbors love that you have not played. The NLP engine identifies artists and tracks that are being described in language matching, the essentially, yeah, described in the language that's matching um, the language used to describe music you already listened to, and surfaces songs that fit your test profile based on that texture signal. And then after this, or as a part of this as well, the audio analysis engine identifies songs that are acoustically similar to songs you have been playing, matching on tempo and all the other qualities that we mentioned: energy, valence, acousticness, and essentially helps curate around this. So all three engines produce candidate songs. Spotify then runs those candidates through a ranking process that removes duplicates. It removes tracks you have already played frequently. It removes artists you already know too well, right? So keeping that element of surprise, but still for something that you love, and prioritizes candidates that appear in the input of multiple engines simultaneously, right? So since the song that scores well on collaborative filtering and audio analysis, and NLP is much more stronger recommendation than one that's only recommended by one system. Um, the Discover Weekly strives to use all the three as much as they can. So the result is the playlist that you get, right, every single week of exactly 30 songs delivered to your account at around midnight on Sunday night, ready for Monday morning, and to get you grooving to the music throughout the week. So, for listeners who want to go deeper into the actual uh, logic or the actual logical process, let's spend a few minutes on what is happening beneath what we have just described so far. The matrix factorization at the heart of collaborative filtering works by taking the user song interaction matrix, which is the large table where every row is a user and every column is a song. And the value at each intersection represents how much that user has engaged with that song, and decomposing it into two smaller matrices. So the first smaller matrix maps each user to a set of latent factors. The second maps each song to a set of um, latent factors. The word latent here means that these factors were not defined by humans in advance. The algorithm discovered them by looking for patterns in the data, right? So a latent factor might capture something like preference for acoustic music, or preference for emotionally intense tracks, or preference for music in a particular tempo range. But the algorithm does not label them. It simply finds that these dimensions of variation in the data are useful for prediction,